really appreciate your feedback. So we'd also like to use this opportunity to ask if you want to present at future ISCO UK meetups, please do let us know. This is really for everybody, for practitioners, students, researchers, and everyone interested in knowledge organization or related fields. So the goal of this hands-on series, and I think some of you have joined the previous one, is really to build a community of people who are aware of and keen on using open source tools for knowledge organization and related fields such as data governance and data management. So there's quite a bit of landscape, obviously from taxonomy management to taxonomy publication, subject indexing, etc. And so we're starting with VocBench, which is free and open source web application to build ontologies, knowledge organization systems, and lexicons. So really, our kind of key goal is that by the end of this workshop series, you'll be familiar with some of the features of VocBench and have some hands-on experience with it. And the way we're sort of doing it is we're really having three parts. So last month we ran introduction to VocBench, and this session is about importing data and using Sheet2RDF feature within VocBench. So let me just spend a couple of minutes on sort of logistics. So this session is made up of two parts. So first one, Armando Stellato, who's currently leading VocBench 3 project at University of Rome, will introduce VocBench and give a quick demo of the import functionality. Then we'll have a Q&A break, and then after that, Phil Stacey, who's currently with Barrett Holmes, looking after document management in fire safety, and also with others helping organize ISCO UK meetups. He'll run a hands-on part of the meetup. So my name is Eugene Morozov. I'm a technology consultant, I guess, working with data management, working on data management, data governance projects, but also working with Phil and others at ISCO UK to run these meetups. So I'll facilitate the session and sort of handle Zoom Q&A. So last point before I hand over to Armando is we want these sessions to be obviously interactive. So Phil will run the second portion of it, which is hands-on. So what we did, we set up a shared instance of VocBench for participants, and we pre-created some users and projects, so we don't have to deal with, self-registration and the personal details. So we have about 20-30 users to give away. I think we have more users than we have participants today. So please send us a message on Zoom and tell us if you want to follow along, and then I'll share username and password with you. Once you have this, please do log in, and you'll be ready for the second part of the session. So I think with that, I guess I'll hand over to Armando, who'll talk us through VocBench data import functionality, and we'll see a bit of a demo. Armando, over to you.
Thank you, Eugene. By first, let me thank again ISCO, Eugene, Peter, and Phil, obviously, for inviting me again to give a demo about VocBench. Today we talk about import from spreadsheets. The functionality is not new in VocBench. It's not related to the latest version. It has been around since one of the first versions. I think it was 3 or 4 of VocBench 3. Again, to clarify for everybody, the 3 in VocBench is part of the name. It's the third incarnation of the system that follow-ups after the few initial systems that were developed initially by FAO, and then together with my development team, and finally now we are in this third incarnation of the system. So when I refer to the version, it's not to the 3 or 3 dot something. It's then there is another completely separated counting for the versions. So we had VocBench 3 version 1, version 2, etc. Now we are in version 9.1 that has been released last week, and this functionality, that is the import from spreadsheet, like I said, it was available since one of the first versions of VocBench. There have been a lot of addenda in the version 7 and 8. Nothing new in this version 9, but be prepared to get a few improvements, if you not revolutionary but still very important news in Sheet2RDF for version 10 that will be released in June or July, probably July. So let's go with a demo. I deactivate the cam and I share the screen. So now you all should see the screen of VocBench. And we are going to create a new project. What we are going to do is to take some data that is stored in a spreadsheet. In particular, we will be using Excel, but the spreadsheet system for import is compliant with Excel, with open spreadsheets, and also with basic formats such as comma separated values or tab separated values. So the data that this is not some toy data that we created for making an example. It's a real example that comes from an authority table that is managed by the Publication Office of the European Commission. It's a table about treaties. And we are going to create costs based on the content of this table. So let's create first the project. Just to recap for those that are not familiar with VocBench and didn't follow the last webinar, VocBench offers a few possibilities when creating a project. By first, many are optional, so there are a lot of configurations. The basic idea is that there is a convention over configuration. You might configure a project very easily by just prompting the very core information, or you might go along with prompting more detailed configurations. For now, we will just create a basic project by prompting the basic information that is needed to create it. So by first the project name. Okay, let's say that is a demo about treaties. And then we do not preload any data because we are going actually to load data from the spreadsheet and in order to populate the data set. Let's go with a base URI. I will put the base URI of this data set within the OP, the European Publication Office of the European Commission. So publications.europe.eu/resource/authority. And this is like the basic namespace for all authority tables of the OP, and then treaty, maybe with some less characters. And then a final slash. This is not something related to VocBench, it's about data publication, but just to recap for everybody, by using putting or not putting the slash. The idea generally is that if you put a slash, you are telling that the default namespace and the base URI for all the resources that will be created will be based on this slash. So if I have a resource that is called ABC, then it will be this namespace /ABC. When nothing is prompted, an hash will be used to separate the namespace from the local name. The point is that when you are going to create a data set and not just an ontology, supposedly there is a lot of data that will be published, and so you will probably want to publish it. When you publish as linked open data, you want to each resource to be resolved by itself and not as a whole document. That's why the approach with hash is not good, because in this case the document would be just this, would be HTTP blah 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 and then treaty, and then ABC will be like a section within the document. No, so if you try to resolve these, actually the system will resolve the whole description of treaty and then get a descriptor ABC within it. What we want instead, when we have a large data set, is that each resource is a resource per se on the web. So we will use the slash here. And now another two important points. The model, that is, it implicitly is the semantic model. We are going to define a knowledge organization system for this authority table. So we'll use the SCOS vocabulary. The lexicalization model, we have two possibilities. We can use SCOS. Okay, we can even create hybrids, like a set of SCOS concepts with RDFS labels, but this is not a common choice. Normally, if you create a knowledge organization system, you are going to use the terminological properties that are provided by it. And there are two choices. One is SCOS, for having a set of properties like preferred label, alternative labels, and hidden labels. Alternative label, like the name suggests, is just synonyms, alternative expressions for the terms that you are, for the concepts that you want to describe. And hidden label is usually, it's not commonly used now anymore, but it's for those labels that do not really represent a concept, but might represent common misspellings, typos, etc., that are so common that you might want to instruct a retrieval system to also look for them when to point to when a user searches for concepts, and use that as an anchor also for your concept. So they are called hidden because they are not shown normally when you're browsing the resource, but they should be taken care by any system that is implementing retrieval on a certain vocabulary. SCOS Excel is the reified version, offers the reified version of these properties. What does it mean, reified? It means that the properties are not just, the labels are not just literals, that is strings that are attached through properties to the concepts. In this case, the labels will be first-class citizens. The label will be resources in time. They will have their own URI. And then they will have a string attached to another property, that is called literal form. Why this reification? Why making a label a URI and then attaching the literal form to it? It's because we want the label also to be described by other properties. For example, I might have properties that describe relations that occur between labels and not between concepts, some sort of lexical relation. Or we might want to provide metadata for the labels as well. I might want to know when a certain label has been created, and I might want to know who is the user that proposed that label, and so on. There may be a lot of metadata you might attach. So in this case, the solution is to reify the label, that is to create an object that represents the label, a resource, and then provide a string describing what it is, the label itself. So we are going to use SCOS Excel in our example. Then there are a certain sort of options for VocBench, for connection to remote repositories, for configuration of them, etc. Other configuration options, but we are not going to use any of them. This suffices for our example. So we have created the treaty project. And now let's look for it. Demo treaties, here it is. I open the project, and the project is obviously empty. As you can see here, there are just basic classes of the OWL ontology and SCOS ontology. I recall for all you that this is just a selection of classes. I mean, there is the SCOS and SCOS Excel vocabularies that have been imported, but you only see OWL thing here. If you want to tinker with OWL, actually, you have the possibility, for example, to select another resource. The RDF resource class, and you can select also which classes you want to see. Supposedly, for example, RDFS class, and when you do such a thing, then you can see now more information here. And so it is possible to actually select what you want to see in the class panel. Anyway, this part now is not important because we want to focus on concepts. So let's go with the import of the spreadsheet. But first, let's create some static data that doesn't need to be imported because it's fixed. So, for example, we want to create a concept scheme that is used for all the concepts in the COS. So let's create the scheme. Let's call it treaties. This is the label for the scheme, and then as a URI, we can use a common practice that is to use exactly the namespace itself as a URI for the concept scheme. So this element is called treaties. As you can see in VocBench here, especially for SCOS, for the SCOS parts like concept schemes, concepts, collections, the rendering is activated by default, because usually these elements are represented by non-evoking IDs, while they have always labels at the very time that they are created. So if I remove the rendering, I can see the URI of the resource, or here I can simply see the label that I chose to show. Now let's go to the import system. I'm here in Sheet2RDF. It stands for Spreadsheet2RDF import. Here I'm browsing a file that describes the treaties. As you can see here, the treaties are described by various files. I can open the one that I just imported in VocBench, and I can show you the content in Excel. So you have various columns, and the columns contain the definition through the header of the element that is being represented. And then for each treaty that is described in the Excel file, there are different values on that column that represent a characteristic of that treaty. Notice that you shouldn't reason in terms of one column is exactly one property. Maybe one column is containing some content that needs to be described through a more complex solution. So again, the idea is convention over configuration. What is simple should be simple to do. What is more complicated should have the tools to be managed properly. So now I have imported the Excel file within VocBench. As you can see here, we have a representation of at least the first elements in the first records in the Excel file. And then here we have the columns. There is one assumption that we are doing, because this is the most common way of usually of filling Excel files for data. That is, each row is a record, like in a database. Each row is a record, and then the columns represent the various characteristics of each record. So when you see treaty classification, this holds for all the records, where each record has a value on this column. So first thing, we have to decide which is the URI that represents the element, the resource itself. That is, this whole row is a treaty describing all these characteristics, but which is the subject that binds all of them together? We have a kind of special binding here that is called subject mapping. We select here the column that will be used to construct the URI of the main element. Who are the elected elements? I see here a column called ID, but let's reason a little about this. Here I'm not talking only about VocBench. Let's think also about the process of importing data from a spreadsheet. I see here ID, but I also see an authority code that it appears, and okay, just trust me, it has been verified. This is the case. This authority code is de facto also an ID, because it's always different in every row. It could be used indeed as an ID. So why it's not the ID? Because, okay, probably this data in turn comes from a database, and then there was the need to have, or at least the choice, to have a progressive number indicating the record. That's why we have this ID here. But indeed, we could use some ID which is more evocative. Since we have for sure clarified with the publication office that this authority code table doesn't contain duplicates, we can use this one as the ID for the treaty. So I select from here, from the subject mapping, I select the authority code element. And then I might want to say, okay, this is a concept. So there is an entry here telling to assert the type for the element that you are mapping. And we want to take the SCOS concept element. Finally, how to create the URI? Let's just say that I choose the default converter. The default converter does this process. There are, as you can see here, there are various converters with different options for being invoked. You can see here the different signature of each converter. For example, this one has 3 signatures, no, the randomic ID generator, and the default converter has just one. The default converter has no parameters. It's very simple. It just takes the feature that is given as an input, in this case the value of the cell or the authority code column, and then this is transformed into a URI. How this transformation takes place? Well, basically you will be using the base URI of your data set, and it will be concatenated with the local name that is, with the local name, and the local name is taken from the column, from the cell present in the selected column. So in this case, the first one will be SICA 1951, TIC 1957, Euratom 1957, etc. Actually, it will not just be this concatenation, because the value of the cell would be sanitized with, in the ETL jargon. It means that you will get that value if together with the base URI, it is compliant for creating a valid URI, then that one will be used. If there are characters that are offending the format of a URI, then this will be replaced in order to create a URI. In this case, for example, if there are spaces in the value, the spaces will be replaced with underscore, and so on. There are some other choices, but in general, let's say that for the kind of characters that are used in the authority code, I expect that the value will be taken as is and just concatenated to the base URI. So we use this transformation, and there is also an additional option here, additional predicate object. With this choice, you can add further triples to describe the subject that you are creating. Usually these further triples come from the description of the concept itself, which is distributed across the various columns of the spreadsheet. But what if there is some fixed value that you want to add, for example, that is not available in any column? Okay, one trick is you alter the original Excel file, you put a column with the value that you want, and it's done. But if it's a fixed value, and why scrambling the original Excel file? Just add this value. So this is the solution. There is an additional predicate object here. That means that by keeping the same subject, then you add a predicate and an object. And you can add an arbitrary number of this predicate and object. In particular, we defined initially, if you remember, a concept scheme. No, the concept scheme is a fixed concept scheme for all the data sets there. So what we want to do is that we say that each concept is a top concept of that scheme. So now we can even select the scheme again through the help of the user interface. And here we are. So let's look. The subject mapping now is green. It means, okay, the subject has been created. This column has a special character here, this S, telling that this column has been used for the subject. Notice that you can still use this column for something else, but so that's why we have a separate subject mapping element, because you can use a column, for example, as the element of a subject, and again use it for another property. For example, you could create the URI of the subject by creating a random ID that is set by the elements that are in the certain column. And then you can reuse, obviously, that column as for the labels. So the idea is we keep them separated. One thing is the subject mapping, that it can be based on a column. And one thing is then reusing that column for something else. So, okay, now we show how to see them, because we can improve this piece by piece. Now, so how to produce now the transformation. Okay, the transformation, this is a kind of wizard, but the transformation is based on a language that is called Perl. And this language is a transformation language for transforming feature structures into RDF content. The feature structures are a common, very simple representation language in which there are simply two things, features and values. A feature can have a value. The value might be a simple element like a string or a number, or can be a feature itself, and thus in turn can have a value. And with this, you can create arbitrary complex constructs, but made with very simple elements. There is no namespacing, there is nothing special in feature structures. You just create these variables and you use for anything. Feature structures are commonly used by information extraction engines, such as, if you're familiar with these things with natural language processing and similar fields, with system engineering, text engineering systems like UIMA or GATE. In particular, also, we have an extension of UIMA that is called CODA, that is for acquisition of knowledge from unstructured content. We reuse this element across VocBench in different applications. For now, it is used in two applications. One is Sheet2RDF, and the other one is the one for the acquisition, for the creation of custom forms. In Sheet2RDF, there is a fixed part of the system that transforms every spreadsheet into an equivalent feature structure. So our language Perl is applied then to the feature structure that is produced after the Excel file in order to produce RDF content. So let's see what happens when I click here. This is the code of the transformation. Please notice that I will show you the code and how it works, but at the current level of Sheet2RDF, I would dare to say that practically any transformation that you might need to do can be done from the wizard. The wizard are certain very simple configurations. And like I said, then there are configurations that allow you to perform more complex configurations, but more complex actions. But in general, now everything that you can do can be performed through the wizard. In any case, we always show the code so that if you want to tinker with a transformation in ways that maybe you don't even know how to do with a wizard, but you are familiar with the transformation language, then you can do it here. Anyway, just to explain what happens here in the transformation, we have the declaration. We have two sections here, the node section and the graph section. The node section explains how to create the nodes that will be the resources that will be reused in the graph section. The graph section creates the triple that will populate your data set. So in this case, I'm only creating a node. It's called subject. It's just a variable here to be used. It will be created as a URI. And the third element tells you which is the value that is fed for creating this URI. And it's the value of the first column. And the first column, the columns are numerated starting from 0, numbered starting from 0. So this is column 1. And then there is the graph. Two triples have been written, one telling that the subject is a concept, and the second one telling that the subject is the top concept of the scheme that we defined before. So even here, it's quite, let's say, intuitive. In any case, we prefer to create a wizard so that you might even skip the part related to the transformation. So let's see what happens when we run the transformation. These triples have been created. You may see that there are different colors here because each switch of a color represents a new line in the original spreadsheet. When I click here on any triple, you can tell which line it comes from. Okay, so basically here we have two triples. The newly created URI that is CICA 1951 concatenated to the base URI, declared as type SCOS concept, and then again the same element declared to be a top concept of the concept scheme 3D. Now let's go ahead and map more things. Sorry, I went quite slow in order to explain all the details. Now we will go a little faster. We are going to transform now the ID. One could say, okay, but the ID was just an ID, and we decided that our new ID is actually authority code. We could just trash it. Yes, absolutely. Trashing is a possibility. You can do it this way. You just ignore it, or just to have a mark reminding you that you ignore it. You can decide to put explicitly a mark telling that is ignored. It would become gray. It's exactly the same thing as staying actually with a black color here. Simply will be ignored because no transformation has been described. So this graying by ticking this cell is just to remind you that you are not going to use this element, but we are going to use it. Why? SCOS provides a very useful property that is called SCOS notation. SCOS notation is a property that connects to IDs which are used in legacy resources, legacy versions of your resource. It might be practical, for example, if somebody has a software that is based on, for example, database version of the Excel version of these authority tables, and they want to know, okay, the element that you have just created, what is it referring to in terms of my IDs? Instead of analyzing the content and trying to guess, you might have an explicit way to do that. You might decide that in your RDF data that is using other elements for creating the main URI of an element of a resource. At the same time, you might keep a property telling, okay, but this was the legacy URI that was used in this legacy resource. And you can have even different legacy resources, because maybe for a certain authority table, you might have a URI that has been used in a certain format in the Excel format, and another one has been used in a database. And maybe there was some ID that was used in the paper version of an authority table, who knows what. So you might have different legacy version of these things, legacy IDs. So one thing that we can do is to use the SCOS notation property in order to create a binding to the old IDs used for these data sets. If we want to do things properly, SCOS notation requires the definition of a dedicated data type. So we might call legacy ID, for example, treatise legacy ID. And this, we're going to use these, instead of putting a generic element like a string or a number, we decide to create a specific URI. So our resource will be typed by telling, okay, this SCOS notation points to a legacy ID of the treatise table. Let's go back to Sheet2RDF, which still keeps in memory its status. And now let's configure ID to point to a properly managed version of the content. We use here the simple graph application. Simple graph application means that we are just going to use the subject that we defined before through a property that is associated to the column by a proper transformation of the content in the cells under the header. So we select the property here, that is notation. Here it is. And then we select the data type. Here is the treatise legacy ID that we just created. And now we simply apply a default converter. We create a literal with the data type treatise legacy ID that we defined before. We give a name to this, we call it notation. And here it is. Okay. Again, everything is done through the wizard. I click here just to show you the improvement. And there is a new node that has been created. This node, again, I remind you, this is just a variable within Perl. Then it's lost after we create the RDF, because it must be resolved into values. In particular, this variable is row by row, is always instantiated with the value that comes from this column. The value is transformed into a literal, so into a string, which is typed with the type treatise legacy ID, with the data type treatise legacy ID. You will notice that this column now is green. The green means that the column has been mapped. Notice the graph. We have added one more triple. Subject, again, because this is another characteristic of the subject, the property that we chose. And the value notation, this dollar notation is a reference to the variable that has been described here. And it tells you that we are adding the value that has been created from the column through the property notation to the subject described before. Why everything is under an optional? this is a default choice of Sheet2RDF. Every time you add a column, it is considered non-mandatory. That is, if a value is missing here, then you will now have a node that is being created, and then this creation will fail. Notice that there is an approach that is very similar to Spalcall. You have to imagine that this is a whole graph. If there are variables which are unresolved in this graph, then the assertion of the graph fails and everything fails. That means that simply that record will not be stored. If you want that the record is stored, even though some of its information may be missing, then you have to put this information as optional. So by default, this is what happens. If you don't like this, you can remove this thing, but be prepared. This means that if that information is missing, then you will lose the entire record. Okay, let's go ahead. We are not going to transform all of them. We are close to the end. I'm just showing you a few examples. This is another interesting example, 3D classification. It contains some codes. You can see here there are repeating codes. There are not many. What is the best representation of something like that? You could think that you might decide, for example, in some cases to filter all those treaties depending on the kind of classification that they have. So I guess that in SCOS, the best representation for these things is to map them as concept schemes. So there are two things that you want to do. You want to define concept schemes for all of these elements, and you want to bind, for example, CICA 1951 to the scheme found. How to do these two actions in one single, because there are two actions. One thing is declaring the scheme, one thing is attaching the scheme to the concept, or better, attaching the concept to the scheme, to the scheme. Okay, we are not going to define the scheme manually as we did for the single scheme that binds all the concept. We are just going to create it by reusing again the same approach. So I'm using again a simple graph application. Here I'm selecting a property, and again I'm telling top concept of. The range type is a resource, so it's a URI, but I'm telling that in turn, that element as a type in particular is SCOS concept scheme. You might wonder, how did he know that he had to suggest concept scheme? Because some decisions are implicit. If you're going to use the property top concept of, and the range of that property, you see this is grayed out. I cannot change it. This is the defined range for the property top concept of, which is concept scheme. So automatically I'm getting suggest the type to be concept scheme. I can, however, refine it. If concept scheme adds some subclasses, I would see them here and I could refine the choice. But in any case, here there is only one class, so this is the only choice possible. What is explicit in my configuration here is that I decide to explicitly assert that those URIs that I'm just creating as objects of the property top concept of need to be defined in turn as concept schemes. And finally, I'm creating again the URI. Again, you choose to create the default converter because I just want to concatenate the name access, other, amend, etc. to the base URI. So that's all. Again, I update the transformation. You see again a new element called scheme. Actually, I should have called scheme. Let me see if I can add it. Oh, I will do it later. So this node is called scheme URI, again, taking the value from the column 4, that is 3D classification. And here you have an optional. As you can see here, two triples are bound under the same optional because these two triples are related to the same transformation. So it's okay that in a sense, they are in end between them. If one of them, for any reason, fails, then there is no reason to write the other, okay? But all of them, the two of them put together, are optional with respect to the rest of the data. So if something here is not defined, this is not a problem. This part will be completely missing, and it's optional, so the rest of the part will be written. Let's go now to creation date, and I think that we can at least stop on this file, then I will show you what happens when we create another file. Creation date, it would be nice to use well, a very common property that is doubling core created. but I don't have that ontology loaded. So I have to load the doubling core ontology. And here, this is the occasion to see another form of data import that is more explicit through semantic web standards. I can decide to import it from the web. I could import it directly from here by using add import from web and putting the doubling core namespace into it, a URI of the ontology, sorry. I could decide to import from the mirror because maybe I already have this one within, probably. Let me see, here it is. You see, DC terms, and this would work. Another possibility is to use the dataset catalog. So this is just a preview of what you will see in the next seminar. I can use the linked open vocabulary service to import DC terms. Let's see if by this simple search I get something. Here it is, the DC terms. So because I'm lazy, maybe I didn't want to get the URI of DC terms, but I can use this service to retrieve it. And here it is, this DC term ontology is here. If I go here on the properties, I will see a lot of them probably. Yeah, description, date. You see, all of them have the DCT prefix, which has been associated in the metadata, in the prefix namespace mapping here, DCT, and here the URI of the ontology DCT. So let's go back to Sheet2RDF. Now I'm able to create this binding. Creation date, I want to bind again through a simple graph application. I want to take the property created that now is present in my dataset because I imported the ontology. The data type needs to be the date. Where is it? Here it is. Normally it should be done automatically, but I guess that in this city, the range is simply literal. So we have to do it manually. If the range was explicitly XSD date, then it would be automatic. And as I selected date, then I'm prompted with a converter that best fit the choice that I made. In particular, the date converter has been added. And this is what I get. Okay. Okay. Again, we go like this. And I get this new element, date create, that tells to transform the value column 5 into a literal by using a transformer for dates. You can see here that it was just written literal. URI, sorry, here it is just written literal, but with the specification of the data type to attach to the definition of the literal. But there were no other specification. Here in between round brackets, you have this coded date. The idea is that there is a default converter, that one that I selected before. And when you select the default converter, that does certain basic options for URIs, for literals, and so on. That is basic sanitization for literals, basic sanitization for URI by attaching the base namespace, and that's all. You don't have to write anything else, but you can specify to use specific converters like this code date converter that, for example, verifies that the value in input is a proper date according to the ISO, I don't remember which which number, I-8356, I think, no, I don't recall, for date formats. And if it is not, it tries to parse the date that it finds on the Excel file and to transform it according to the standard that is adopted, the ISO standard that is adopted in RDF for dates, in particular in the XSTD schema. Now, this element has been used again in the triple here to be associated to the DCT created property to the subject. Let's see what happens when we transform all of this. Again, now we see with the usual alternation of colors that there is a SICA 1951 of type concept. It is the top concept of the General Scheme Treaty. It has notation 3001, that is the element in the first column, with this specific data type. It is also the top concept of a specific classification mapped as a SCOS concept scheme, and here describes this classification as being a concept scheme. And then you see here the SICA 1951 has been created in 2011 on the 19th of May. Finally, what you can do, you can export this information in case you want to load somewhere else or you want to check it, or you can directly add it to the dataset. So now if we go back to the concept, we refresh the view here, and here they are, all the concepts with their description. You can see here the DCT created, you can see here the calendar icon and the value, and in between with the snippet, you can instead with the tooltip, sorry, you can see the description in RDF, no? But here you have a user-friendly view, so the year as it appears also in Excel. Here you have the notation by showing clearly the value, and this thing in orange, maybe it's a little small if you have a smaller screen. Anyway, here it describes the treaty's legacy ID, that is the data type being used. As you can see, the element is a SCOS concept. You can see it with the green icon of the SCOS concept, and is the top concept of the cons and the treaties concept scheme. So if you go here on the concept schemes also, and you refresh, you can see all the various schemes. If I deselect here and I select, for example, found, I can see only those concepts that belong to the found scheme. And here they are. Now, what are you missing? The labels. These are just codes, dates, numbers, but no label. The label come in a separate Excel file. So let's go for the last part of our demo. Labels, here they are. You can see that there are some elements which are the same, and then there are the various labels in all the languages in which the authority table has been translated. So let's take the subject mapping again. We just need to reconvert at least the subject mapping in order to create the same binding to the same element. So authority code, I use the default converter. So I'm sure that I'm deterministically creating the same URI. Sorry, this was my mistake. It was like this. And I needed to create the subject mapping instead. Authority code, default converter, and that's all. Okay, because I need to describe now some triples. Okay, so now let's go to transform the English. Here it is, English label. And now we are going to create a complex mapping. Because you remember the labels that we are going to describe were SCOS Excel labels. So I'm using an advanced graph application. And here I would be free to write some Perl code. However, it is possible for example, advanced users to prepare some templates that can be reused by others. In particular, in VocBench, there is one template that is already stored, so it doesn't need to be specified, that is specifically for SCOS Excel labels. You can see here, I make it larger, you see the subject will be attached to a predicate to the X label, the SCOS Excel label that will be created. The SCOS Excel label will be defined as a SCOS Excel label, and will have a literal form that is the literal form that you are creating. There will be two generators, one URI for the resource itself, because like I told you before, the SCOS Excel label is a ref.
Armando, sorry to interrupt. We're about out of time, and
okay.
just
want
want
it quickly so to show what happens, and that's all. So did I map it? Okay. Result here. I hope I didn't lose anything. All the triples are here. And that's here, the labels that have been represented. You can see here the flag, or you can use language code, is the same. And this is the content that has been imported. Obviously, you can do the same for all the other labels in all the other languages. Well, there is a lot more that could be added, but I think that is quite a thorough introduction to the system. Sorry for taking a little longer, but it was not obviously when you do an ETL process that you have to extract information from some content and to transform it into the destination. It takes some time, but I hope that you can see that through the wizard, all the operations are pretty straightforward. Obviously, it requires the knowledge of RDF. You at least must know how to represent these things in the end, but you are very much supported by the system in doing so. Sorry, I leave the word now to Phil.
Well, thank you very much. That was very interesting, and I picked up quite a few points there. I've been using VocBench for a couple of years, and I'll just share my screen now. What I think we'll do is we will just do Q&A at the end. Right. So I think Eugene's given quite a few people logins and what have you. Can you just let me know by raising your hand that you're able to see the projects list for the people that are logged in? I've got 2. Is everybody else able to log in? Yeah. Okay. So what you would do is your number will be different than workshop 02. It'll be 04, 06, or what have you, whatever Eugene's assigned to you. And then you click access. And just to let you know, I sent a link for what we're going to go through. So if you can't follow along right now because of computer or what have you, you can also do it a later time. And you've got the files, and I think Eugene will leave that running for a couple days. So the first bit, what we'll do is we'll go up here to global management, and we will go load data. Now, on all of the projects on the system, it's got the subject predicate object.com as the URI. So we're first uncheck that, and we're just Control A. And what I'm going to do is delete that. Is everybody okay with that? If you want to raise your hand if you're okay. Right, okay. And for the name, so we'll go down here to the landing page. We're just going to call this one Build Vault Guidance. And I'm just going to, oh, wait a minute, we don't need that for the project name, sorry. For the base URL, we're going to call it Build Voc /resource, and I'll just copy that. And I'll just put that into the base URI, sorry. And then what I'm going to do is I'm just going to browse, and this is a very simple vocabulary that I started a couple years ago for the construction industry, and I've been using VocBench for it for the last 4 years on and off. And it's a very valuable tool. And I haven't been using it on the level that Armando's just presented. I use it quite on a simple level. But for example, I've just sent you in the link to just a section of the vocabulary that I've created. And in this particular one, it's a turtle file, which I find works quite well. So NTs and turtles, when you're importing, there doesn't seem to be too many problems. And then, so we've changed the URI to the base URI, and then we just click submit. And sorry, we just went through that, and we will get data loaded successfully. Now what we're going to do is we just go over here and have a look at the data. So we click data. And if anybody was on the call in April, we talked about there's no concept scheme selected. So you go into scheme, and then we just select, there's only one scheme in this particular vocabulary. And then we just go back over to concept. And I don't know if anybody recalls last time, but one of the things that I always turn on in VocBench is the type ahead. So if you go to the settings, and I've already completed it. So it's just down here almost at the bottom where you go enable auto completion during typing. And you can restrict it to whatever language you'd like. But in this instance, this whole vocabulary is in English. Apologies for people that's not their native language. And then you just click OK. And the reason I'm doing this now is I'm just going to show you that this concept that the set of concepts that we're going to import doesn't exist. So I'll just start typing in access. And you can see there's access point, access room, so forth, accessible entrance, accessible threshold. And as I mentioned, this is for the construction industry, and most of these terms are from approved document B. So that's relating to fire safety. Accessible threshold is probably related to another approved document, access to buildings and so forth and so on. And then we're going to click cancel. Now we're just going to go back through quite quickly what Armando was talking about, but maybe on a bit of a simple way. So if you go up here to tools and then go Sheet2RDF, and I'll just scroll down here. And I've just put down here that we've got 3 panels. So we've got, as Armando went through a lot of detail, the transformation, and then we got the purl, and then we got the triples that come down here. So the first thing we're going to do is we're going to select a file, and this one will be just, these are some mobility definitions. So that's why it says M2. And so we just click on that Excel spreadsheet. And before I do that, I'm just going to open it up real quick and just show you what it looks like. So I should have reformatted this a bit nicer, but I basically scraped this from one of the approved documents. And one of the things that I like to use in VocBench a lot is let VocBench identify the URI. So in our instance, I've left that blank, and we'll talk about that in a second. So I've set the preferred label. It's got a long definition, and then we've got a broader, if it has a note, I'll just expand that just a little bit. If it's got a Scots notation, if it's broader, and if it's part of a collection. So about 6 months ago, I imported about 300 new terms to my vocabulary from the approved documents. And so what I did is I set up a very simple spreadsheet that the main 2 bits that I wanted was the preferred label and the definition. because I was going to use that for automatic indexing and to train a model. So I just thought I'd show you that real quick before I import it. So it's a very, very simple spreadsheet that after you kind of get it set up, and you've got one now set up, that you can basically just put in a quick label, a quick definition, and import it into your vocabulary, and then build upon it. I mean, there's some great new features that have come out in the last year or so in VocBench as far as being able to do multi-select and what have you. And if we get a chance, maybe on the last workshop, we'll go over some of the production features that I use when I'm creating or deleting or modifying my vocabulary on a week-to-week basis. So we're going to select the Excel spreadsheet, then we'll click open. And you can kind of see there that it's recognized. So it's all green. So what Armando was showing, excuse me, is how you can kind of add properties and organize it in another way. I find on a simple basis to just kind of have a spreadsheet that's set up, and then I can just put lots of terms in there and definitions and so forth. I guess it just depends on what your use case is. So we've kind of, we click the browse button and we've grabbed that. And the next bit, we're going to go to panel 1 is the data sheet preview. So I'm not going to click the play button here. And the reason is that I found over the years using Sheet2RDF is it's easier for me, and this is just me, to manage it through the Perl. So one of the other files that was available to download was a Perl file. So we'll click load, and it's just this very simple Perl file that actually Peter, that's on the call, helped me sort out. One of the nice things is that Eugene and I were talking the other day, and we've added the concept scheme into it. So you could just change this out. So if I made that a bit bigger this way, you could just change this out to your concept scheme and, you know, add and subtract whatever columns that you have there. But one of the great things is, as I mentioned, is this random ID generator. So what it's going to do is it's going to just generate IDs, and I don't need to worry about it. And I find it very helpful. So that's the Perl editor, which we haven't done any editing at all. But I think if you review the video or you were taking down notes, Armando went into a great level of detail that is very helpful, and I'm going to have a look at that a bit later. So the next box is the triples generation. So you just click the play button up here, and it generates the triples. And I didn't know about the colors that, so if you click there, that's that concept. And then you go down, I didn't know about that, but that's very handy. So you can just basically check to see which ones have imported and the triples that it's generated. As you can see, there's preferred label. It says general access there. Before I click on the add triples button, I just wanted to mention, and we're coming to almost the end of the hands-on, because I wanted to keep it very simple so that it may be something that you want to take away and try yourself on your vocabulary, bring it into VocBench and, you know, do some updates to it. But what you can do, and I've used this from time to time, is you can just export those now. So you don't even need to bring them into your vocabulary. And I've exported sections. So I basically use VocBench for transformations from CSV or an Excel spreadsheet. And I've saved that as a turtle file. So it may be of interest to some people where you may have micro schemas that you're creating and you want to just save them off individually so you can manage them a little bit differently. But in our particular instance, we're just going to click add triples. And we get operation done, which is very good news. And we click OK. And so if we just go back over here to data, and I'm just going to click refresh just there for a second. And I'm just going to start typing in access again. And if we just scroll down, you can see access there is one of the new concepts. And if I click the search there, select that, and it brings up that concept. So that's about it on the follow along. And back over to you, Eugene.
Okay, thanks, Phil. Let me get the video. Right. Well, I guess we probably have about 10 minutes remaining for the Q&A. So before we jump to that, just a couple of notes. So as Phil mentioned, we'll keep the instance running for the, well, really sort of couple of months probably when we want to go through this workshop series, so you can bring your own vocabulary and see what the import functionality looks like. And yeah, if you have any questions, I think Phil, myself, Armando will be very happy to answer these. Haven't seen any questions in chat so far, so maybe it's all crystal clear and people just happy to use it.
Or the computer, it's too complicated.
Maybe, who knows?
Ask anything.
One thing I'd like to mention is there's just a very quick 10-question survey as you exit the meeting. If you could do that, that'd be great, just so we can understand a bit about your background and potentially some other workshops. Okay, so no questions today, huh? Well, you did cover a lot, Armando, so I think it's all crystal clear.
But what we'll do as well, I guess, is with the slides, we'll do two things. So first, we'll post video from the first workshop online, so you can look at that. Certainly, this one, the slide deck will include links to the user guide that Armando and his team put together, so you can sort of try different things and play along. I think there's one question from David. Is the recording from the last month's workshop available? Couldn't find it. It's not available yet, so we want to do a tiny bit of editing on it and post it online.
Okay, fantastic.
Okay, right. So I guess.
Thank you very much, Eugene and Armando. It's a great pleasure working with you guys.
Fantastic. So I guess we'll see each other in June then, and we'll talk about versioning and data catalogs. Very exciting topic.
And maybe if we have time, we might talk about some production features, multi-select and bits and pieces. We'll see how that goes.
Yep. Okay, great. Thanks, everybody.
All right. Thank you.
Bye.
Thank you, everybody, and see you in June.
Okay.